Hello, welcome to the workshop. It's Wednesday. We're
Hello.
back.
Hello.
How is everybody?
I'm
Doing
doing pretty
alright.
good myself. I hope everyone in chat's doing pretty good.
Yeah. We do have the commands off during the workshop as well, yeah.
Mm-hmm.
Tell you one thing I do need to sort out, actually. There we go. Turn that down a bit. So,
Mm.
today we're covering something actually that, a few people have asked us about before. And I would actually deem it quite a important thing, really.
Yeah.
Is how to do gestures in Neos. Oh, Rampa, that sucks. Sorry about that, dude.
Ooh.
But yeah, not everyone has the facial trackers, lip tracker, well, facial trackers or eye tracking. So we're gonna cover how to do gesture controls using your controllers. So you can like press buttons on your controllers, hold them down, and all that good stuff.
Mm-hmm.
Or your context menu as well.
And your context menu as well, yes. And
Useful for
if
people in desktop
And
mode.
if we have got enough time to cover it at the end, we're not making any promises on this one, we will quickly go over as well how to assign the facial tracker stuff. Because not everyone knows how to do that one. And sometimes the heuristics don't get all the gestures. I'll survive with enough credits. So, yeah, as I say, we've got quite a bit to cover on this one. So
Mm-hmm.
we may go slightly over, but who knows? We'll see. As I say, who wants to start?
I suppose we could start with Cam on Aegis,
Yeah, we can give
and
that to Aegis.
we
Yep.
can head over to our little station. So over here we have a Rex avatar already set up with a couple of inspectors. And this is the avatar we're going to be doing the gestures on. And the reason we are using a Rex is because if you have ever looked at how many blend shapes a Rex avatar has, there's plenty to work with. As we can see. Oops. And I suppose the first option we can work with is setting up a context menu for, I keep pressing that, for gestures. So I guess I'll start with how to initially set up a context menu, and then we can go from there. So to add a context menu item to an avatar, we can go to the avatar's root and add a new child. I'm gonna call this if I can type, context menu. And since we want this to be a sub-menu, since it will be an item, then when you click on it, it shows more items. We're going to need 3 components on this initial item. And they're all located under Radiant UI, context menu, and it's these items here. We're going to need a root context menu item. We're also going to need a context menu item source. And we're going to need a context menu submenu. Now, with these items, I'm going to first give the context menu item source a name. Let's call it gestures. Color too. How about blue? And we're going to take this context menu item source and put it into the item of the root context menu item. And then we're going to, underneath the context menu submenu, we're going to take the context menu slot itself, grab it, and put it into the items root. What this is telling it is when you press the button, it will search underneath this slot for any context menu item source components underneath it and set up a menu based around that. So now, just since we already have the component we need on a slot, the context menu item source, I'm going to duplicate this slot, parent it underneath, and I'm going to get rid of both the root context menu item and the context menu submenu, because this is just an item. We don't want it to be a submenu or be a root item. And I'm going to call this, well, I'll just call it gesture for now, because I'm not entirely sure what gesture we want to do with it. And here, I think would be a good time to move to Aegis. Aegis, we want to set up a basic context menu component setup so that you can toggle one or multiple blend shapes with a button press on context menu. And how do you do that?
So, there are several different components you can use. You can simply basically change the state between one or another by a toggle, or you can have something even smooth. So I have a list here of like an example of different components here. We can even combine several different blend shapes together to kind of make a unique expression too from it. So in order to start, if I grab onto this avatar and open my context menu, I can actually see that I have that option pop up for me, as it's technically under me as a user, and I can use the context menu, so we can even test it without being in the avatar as well. So in this case, I'm going to have the context menu item here. Let's name this, or, well, yeah, just test gesture would be fine. So I'm going to attach a component here, and we're going to get so in this case it's going to be a toggle on and off, so that's a Boolean. So we're going to have to go to transform drivers, Boolean value driver. And each one of these blend shapes is a float value, so we're going to need to select float. From there, we need a way to toggle these states on and off. So in this case, I'm going to put 1 in the true value. It has nothing to target. So, but before I even assign anything else, if I want to connect this together and make it work, then simply go to Common UI, Button Interactions, and Button Toggle. And I find the target value, which is going to be state. Drag this onto there. And then if I want the gestures, that checkbox changes. So now we need to test it. Let's try blep. Let's make the avatar stick its tongue out. So that works. Alright, but as you notice, it's just instant on or off. Now it's useful if you wanted to, like, you know, swap between different ones and that, but also it only drives one. Say if you wanted to drive multiple, we can go to a category called Relations and Value Multi-Driver. And we also find float. Now, instead of this target field here, actually I'm going to add a list to however many drives you want it. I'm going to drag this over here after clearing it. Then I'm going to drag another one. There we go.
Cheek buff.
Yep. And then we drag the value, this float value, back into the value driver float. So you can put in multiple, but now it's still instant. Now there is also another component you can do, also under transform and drivers. You just scroll down a little bit, and smooth value. And the first one on the top is float. So now we need to clear the Boolean value driver again. And this time, we go to the smooth value floats, where it says value. That's the value it's changing or smoothing. In this case, we're going to take the value of this float here and put it there. Then if I type in the target value 1 or 0, it kind of smooths the value. And I can even change the speed of how smooth it is or not. So if I put in a 1,
Slow blip.
and if I undo that, it slowly changes it. So I can now simply take the target value here, drag it under the Boolean value driver, then open this up with the gestures and toggle it.
Slow blip.
Let's make it a little bit faster. How about wrong field? Hold on. How about a 5?
One note about the smoothing is the higher the number, the faster it will smooth to its target value.
Mm-hmm.
If you entered a smooth speed of 0, it will do nothing.
Yeah, so the slower you want it to be, the more decimal points you have to put it. So if you want it even slower, you have to put like 0.1, 0.01 onward. So, yeah.
Very nice.
So,
Right now, I noticed when you were pressing the context menu item, the button doesn't really give much visual feedback that it is enabled or not.
yeah, it's just a simple button. So if you want to know if it changed or not, you simply have to go into the attached component. And is it under Common UI again?
Mm-hmm. Drivers.
Okay, so Common UI, drivers, value option description driver, and it should be a bool because it's on or off. So in this case, actually right away, I think I'll start with the color by clicking on those boxes there. Make this red, and another one, make that green, and I can actually, has a label option there, so I can make it so it has tongue toggle off and on. Now I could even put a spread in there if I want, but is it really necessary? So we can find the value. I'm guessing that's where it's finding the Boolean value driver. Let's take the state, drag it in there, and for the label, it's all the way up here. Drag that to the label. For the color, go all the way up, find the color, plug it in there too. Same with the sprite, and all these other options if you have that available too. So now, this should already be working.
One thing to note, with the way that the value option description driver works, you'll notice we have a reference value here. Actually, it does work.
Well, it was inverted.
Ah.
So, reference value off is going to be nothing. For the one that we have on, we check that box, and therefore if we go in, right now it's off, now it's on.
Yes, UIX spam. And you have a gesture. And adding a new gesture using this form is as easy as taking the slot that we added all of these components to and duplicating it and assigning new blend shapes underneath the value multi-driver. Although we should probably not have the gestures named context menu, that's kind of confusing. Yes, naming things properly, just like in programming, having good variable names is very important for figuring out what you did later on. Otherwise, you have no idea. Ah, so you're doing cheek puff.
Where did it go? Here it is. Yep. And you can have like multiple different blend shapes being driven, or different values as well being changed by each option here.
Ah, you need to change the label for it. They both say tongue.
Yep.
One thing to note, by the way, is right now when you enable these values, they're set to 1. But if you change the true value on the Boolean value driver from 1 to some other value, then you can change the driven blend shapes to any value you want, even negative.
Sorry, rename it. I will demonstrate.
Negative. That's called underdriving and overdriving your blend shapes. Negative cheek puff. What is that going to look like? Oh. But you'll notice that even though the sliders for the blend shapes only view 0 to 1, you can put any value there and it will still work. It's just a suggestion to go from 0 to 1 in that case. Yeah, it's not cheek puff, it's cheek suck, which, yeah, there are dedicated blend shapes for that too, but we're silly.
So I can simply just type in, put in 4, and it just ends up turning cursed.
Oh. She can float. Yeah. Well, you want a gremlin smile? Poor Wraithrex. Invert all the blend shapes and become a Lovecraftian horror. Yeah, sounds about right. You could totally do that if you wanted to drive every single one of them with a in the value multi-driver.
It would
It'd take a lot, but
take a while. At least for this one.
Mm-hmm.
So, yeah.
That is, I think, a decent means of doing it with the context menu, and I think the benefit to doing it like this is that this allows desktop users to have basic gestures, because desktop users have access to a context menu, and you can toggle things like that.
Mm-hmm. I mean, technically through Logix you can as well, by taking keyboard inputs as well, too.
Mm-hmm.
You can find where that is, too, once you cover it.
Which, speaking of logics and gestures, I think that's where we can head next, and that we can do gestures with components like this, but you can also do it with logics. And since we already covered multi-tools, I'm going to bring out my handy-dandy multi-tool, and to start with doing gestures using logics, we need a controller node, and well, we need inputs from your controllers. If you're a VR user, we can get to desktop inputs a little bit later. But controller inputs can be found under Input Devices, Controllers. And here we can see there's a bunch of controller inputs for your various controllers, but for now we're going to stick to the standard controller, which is a controller node that works with all controller types regardless. I think even if you're in desktop mode. Now the controller nodes have a bunch of outputs, which are all of your controller outputs. Things like if you're pressing primary, if you're pressing secondary, if you're pressing your menu, etc. And it takes two inputs: a user, which is the user that you're getting the controller inputs from, and a chirality node, which chirality means handedness, left hand, right hand. So for our user, for now, since I want to test this without having to be in the avatar, I want it to use my controllers even if I'm not in the avatar, and to do that, I'm going to plug a user in here so that it will always be me. And to do that, I can go under users, user from username. I'll spawn this out. And under the username here, I'm going to type gravy. And if I pull out a display node for this by grabbing and pressing secondary, we can see, look, it's me. Great. Now we need to define a hand, which is the chirality of the chirality node. And to do this, instead of having to scramble in here and find a node, I can just pull out an input wire and press secondary to create an input. This is an enum input. Enum short for enumeration. And let's have it be on my left hand for now. Now, if I pull out a few display nodes for some of these, like whether I'm pressing primary or secondary, if I press my trigger, it's true. If I press secondary, that's true. You can see. Well, I'll cover that very briefly. That is a custom thing that I made, which allows me to align nodes very nicely. This is something on my multi-tool. It's also available in my public folder. Shameless plug. Anyhow, I'm thinking here, we just to cover the basics, we can use these values to create gestures, and based on various combinations of these values, and we're also going to be using this here, which I'll get to in a moment, we can control gestures with just our hands, no context menu or anything like that required. So I'm thinking the first gesture we can make is if I'm pressing both primary and secondary. So if we look at these, I have to be pressing both of these. I want a gesture to happen when both of these are true. So we can combine two bools with operators and, which has the ampersand sign. We plug them both in. Then this value will only be true if I'm pressing and holding both secondary and primary, not one or the other or neither. They both have to be true. That's how an AND works. It's this value and that value, and as many more as you want. But in this case, we just want 2. Now, next one I want to make, well actually before I get on, I can show how you can use a Boolean value to control a float value. They're not the same type. One is a bool, one is a float. How do you even do that? Well, similarly to our context menu items here, we can smooth a value. We have a Boolean value driver between 0 and a value. Let me go here, so that's a 1, not a -1. Has a speed, etc. We can do the same thing in logics. So we want to turn this bool value, this Boolean value, into a float. And we can do that conveniently with the 0,1 node located under the operators folder. And this one takes a bool and outputs a float. How convenient. So now if I press and hold both primary and secondary on my left hand, we have a 0 and a 1 instead of a true and a false, which is exactly what we want here. Now, to drive a value from logics, you have to actually change your logics tool mode into a different one. And we can do that with the context menu. We can see here this extract item. Right now it's on interface, but if we click this once, we are on extract drive node. And what this does is this, given a value here, like I'm going to grab, for instance, let's say frown. Given this, when I press secondary, instead of popping out an interface card like it usually does, it pops out this, a drive node with a default value associated with it. And you'll notice that the frown here is now being driven by what? By this value here. As you can see, I set it to 0.5, it's now 0.5. Sad Rex, oh. However, we don't want to drive it with just a static value. We want to drive it from here. So I'll just plug this in. We can get rid of this. And now we have this neat little arrow which goes off to nothing. And if I hold primary and secondary on my left hand now, it is a frown. However, just like previously, you'll notice it's kind of an instantaneous frown. Instant sad Rex. Oh, wonder what happened. So, to make it not an instantaneous change, we can smooth this. And smoothing is located under Math. Good old smooth lerp. We can plug this here, plug the output to the drive, and you notice smooth lerp has two inputs, a target value and a speed, just like our smooth value component. Let's pop out an input node for speed, and I'm going to set it to 5. Let me tidy up a little bit here. Now, when I do the gesture input here, it is not an instantaneous change and is instead smooth based on the speed that we chose. We do have an interesting question about drive nodes. How do you get the drive node without the card attached to it? Every time I try driving values, it always keeps the card no matter what I do. So, for blend shape driving like this in specific, it will spawn out an interface card, but it's not hooked up to the drive at all. That's just how this works. Now, if you are driving something and it's not, specifically these blend shapes, and it's some other value, I guess I can give an example here. I will swap my tool back out to extract interface, and I'll go to our smooth value here, pop out its interface card, and I'm just going to make a value here and say, okay, let's drive speed. You'll notice that it makes a handy-dandy drive node, just like we have over there, except it's connected to an interface card. If you try to delete the interface card, it regenerates, always. And the reason for that, is because the drive is connected to the interface card, and if an interface card has anything connected to it, it must exist. Now, granted, you can absolutely you can completely reassign this. There is a benefit to having this wire here, because say you're driving this value, but instead you want to drive this value, you can just drag it from the end of the drive node to the new value, and it will reassign it. Then you can get rid of that. But, long story short, for drives like this, the card must exist. It doesn't really change anything, whether it exists or not, but with the way Logix behaves now, that's why. And I think that covers that little tangent. I need to reset a couple of values now. There we go. Well, sometimes interface cards just pop out. They are they're a rather old construct of Logix. A little bit finicky sometimes, but there are ways to fix that in some cases. Like, I guess really the only real exception to that is when you're driving blend shapes on a skid mesh renderer, where it doesn't make it. At least not right away. Now, this is the basic setup to doing a gesture, but we want to do more than one gesture. So I'm going to scoot these things over just a bit to give us some more room. Now, let's say I wanted to do a gesture where I'm only pressing secondary but not pressing primary. You'd think you could just pull out the secondary value and use this, but let's say you only want one gesture active at a time. If I press secondary, that one enables for sure, but if I also press secondary and primary to do the first gesture, they're both true. And that's a problem, because we only want one of these true at a time in this case. So to fix this, we just need to check, we need another AND in this case. We want to check is secondary enabled, and we want to check if primary is not enabled. So we want to check if this is false, so we're not pressing primary. To do that, we can use the not node, which is located under operators, and it is the exclamation mark here, which means not. Now, you'll notice it defaults to integer type, but the moment you plug a Boolean value into it, it will automatically change its type to Boolean. We'll plug that in. I guess a basic demonstration of this would be, given an input value, it gives the opposite Boolean output value. False becomes true, true becomes false. And the reason that is needed is because we want to check if this value is false, but and only returns true if both values are true. So, If we look at secondary, it's false, but if we look at not primary and I'm not pressing primary, it's true. So it does what we want. Now, we have this, so I'm going to perform just like we did here. We're going to do 0, 1. We're going to smooth this value with a speed of 5. I'm just going to reuse that output because, yes, you can have multiple... data values can go to multiple inputs at a time, in this case. Yes, logic gates. Logic gates are awesome. They're super cool. Let's see, what's the next gesture we want to do? Let's grin. And this is what happens when you don't set your logics tool to extract drive node. It gets the interface, which gives us nothing useful in this case. So I'm going to delete this interface card and swap my tool back to drive node and grab the appropriate blend shape, pop it out, and you'll see it also made the interface card, but I'm just going to set this aside for now. Just like before, I will plug in our drive node, and now if I just press secondary on my left hand, grin. However, if I press secondary and primary, frown, aw. And of course, if I do nothing, then it's a neutral expression. Now, this is what this is called, where you're combining inputs and using them to do things, is actually called combinatorics. And this is really just half of it. Half of doing gestures, especially when you have access to things like strength and axis on the standard controller, which for my controllers, what these do is, depending on how hard I'm pressing the trigger, this value is 0 and 1. You could potentially use this to, say, control the strength of the outputs by multiplying this value by this number. 0 meaning it has no strength at all, 1 meaning it's full strength, for example. Kuruma, yes, combinatorics. It's quite the word. Now, axis, based on your controller, will be the direction that you're pushing either your joystick, or in the case for controllers that have trackpads, it will be where you're touching the trackpad. As you can see here, I'm touching the top of the trackpad, bottom, right, left, etc. It's quite the word, I know. Okay. So with axis, I want it so that... let me do a little drawing. So I have index controllers, so my trackpad looks like this. By default, the value is in the middle. I want it so that I can do a gesture when I'm touching above a certain point and below a certain point. Well, how do we do that? To do that, we can use axis. And you'll notice it is a float 2, meaning it has 2 values instead of just 1. And we just want one of these values, the vertical axis, the y-axis. So we can split this if we go under Operators, Unpack XY. And this node takes a float 2 and outputs 2 float 1s, conveniently labeled x and y. We just want y in this case. And if we take a look at this value, if I touch the top of my trackpad, it's near 1. If I touch the bottom, it's near -1, and 0 is in the middle. If I'm not touching the trackpad at all, it defaults to 0. So all we have to do in this case is check, and again, under Operators, we want to check if the value is greater than, or less than, or equal to a certain value. And this value, for the greater than, we want to check if it's greater than a half, which would be here, upwards. And we want to check if it's less than or equal to a negative half, which is down here. So now, if I touch the top quarter of my or the top third of my trackpad, that's true. If I touch near the bottom quarter, that's true. If I'm not touching it at all, neither of them are true. Great. We can use this to control 2 other gestures. However, you'll notice that if I'm... let me just pull out a few of these display nodes. If I'm touching the top of the trackpad and pressing secondary and doing another gesture, you'll see once again we have an issue where multiple of these gestures are true at a time. Whereas in this case, as I mentioned before, we only want one of these gestures to be active at a time. So we need to check that these are only true if these are not true. So in a sense, when you're pressing secondary or primary, it overrides these, and these gestures will follow suit. So we want to check. Well, first of all, let's go over here. We want to check if this value and not these values are true. So we're going to need a couple more ands. And I'll plug these values in. Do note that for these, it does not matter which of these, like the order that you plug these in, because it's a matter of all or nothing in this case. And now we want to check if this value and this value are both false. Well, we can do that with a couple of nodes and using funny logic gates. We want to check if this or that, this is OR, by the way, the vertical pipe, it's located right there, directly underneath the not operator in operators. So with this, with the OR node, if either of these are false, that's false. But if one or the other are true, then this is true. And what we want is we want this value to be true when both of these are false, which, well, we can use a not operator. And now, when both of these are false, this value is true. But if any of these are true, that value is false, regardless, which is exactly what we want in this case. So I'll just put these nodes somewhere and plug this in here. Now, if I look at these outputs, if I'm touching the top of the trackpad, true and false, that works just as expected. But if I'm doing any of these other gestures now, these will always be false, even if I'm still touching the top of the trackpad. So these, with these two nodes here, this allows us to override these values and set them to false if either of these are true. Now we can only have one value active at a time. Great. So let's set these up just like these others using the 0 to 1 node. And we're going to smooth it like here. And let's use a smoothing value of 5 as well. If you're curious how I made this little node, that's a relay. You can just grab on any wire and it'll make a relay. Good for wire organization. Now let's look for two gestures we can do. Let's see. We already do blap. Oh yeah, the ears. Let's do ears back. So with the ears back, these are controlled with blend shapes, like so. However, you'll see there's two of them. Now, we can absolutely drive both of these using this one value. Let's see, am I in drive node? Yes, I am. I'm going to extract a drive node for ears back left and ear back right. And with the way that data works, we can just plug this into both of these drive nodes, like so. And when I touch the top of my trackpad, the ears go down. Both of them in this case, even if they are two separate blend shapes, like so. And I suppose... let's see, let's do ears up. We have ears back and ears up, based on if you're touching the top or bottom of whatever this axis is for your controller, be it the trackpad or the joystick axes. I'll plug these in too. Right there. We have a bunch of these values floating around that I'm going to delete. We also don't need you. Now, if I touch the bottom of my trackpad, the ears go up. Or down if I touch the top. Oop. And if I press in, it's grin. And if I press both secondary and primary, it's frown. There. You now have 4 basic gestures that are all mutually exclusive due to our funny gate logics here, our combinatorics. And say you have all of this logics and you want to save it to your avatar. Well, I'm just going to add a child to some random node here, move it to our avatar root. I'm going to rename it gesture logics. And just like many times before, I'm going to set the packing root to it, hold secondary, aim at our logics, and let go. Although I did just remember one thing that I forgot to get back to, so I guess I can demonstrate how to unpack this logics. Now grab it, and choose unpack child and connected nodes. The thing that I forgot is, remember at the very beginning, I made this user from username so that I could control the gestures of this avatar even when I'm not in it. I might not want to do that, actually, and I might just want to control the gestures while I'm in the avatar, so I'm going to replace these 2 nodes with a handy-dandy node underneath slots. It is getActiveUserSelf. What this node does is, if you're in the avatar, it gets you. If you're not in the avatar, then it gets whoever else is in the avatar. So it updates the user dynamically based on who is wearing the avatar in this case. Granted, you can also just hold the node and it will still work, but that's just how the node works. Anyways, we can pack the gesture logics back like so. And that would be about the basics of gestures. Now, if I grab this avatar, we have gestures here with context menu items. Oh, that's cursed. Or, and on my left controller in specific, I can touch the top, bottom of my trackpad, or I can press in, or press in and hold my trigger and do 4 different gestures as well. Now, there is no one kind of gesture system. It's really up to your preferred use case, how you want to set up the blend shapes, how you want to control things. But this is one method, a couple of methods that I think are beneficial for new users getting into gestures. Boop, boop.
Yeah, definitely. It's as I say, the logics way is probably one of the best ways to do it because it allows a lot more customization.
Mm-hmm.
So
you can set it up any way you like. It's just a bunch of combinations.
exactly.
Now, we do have a little bit of time here, and as Wraith is demonstrating, say you don't want to have to control your gestures at all, and you just want to gesture yourself. Like, you know, if you want to smile, then you actually smile. If you want to wink, you wink. Like so. Well, for those who have eye and or face tracking, there are a couple of components that allow you to set this up very easily. So, oh, and one thing I should note is you can set up an avatar to set up these components automatically, but it might not detect all of the proper blend shapes, and we'll see if it happens on this avatar. But if you want to set up an avatar blend shapes from scratch, you can find the various components underneath Users, Common Avatar System, and depending on if it's for face or eye tracking, we can go under Face. Actually, they're both under Face, never mind. We have under here a bunch of components relative to eye tracking, mouth tracking, the eye manager, etc. But for face tracking in specific, what we're interested in is the avatar expression driver. Now, this component, given a data source and other things, and a multiplier, and some expression drivers, it will drive the expressions based on the input from your facial tracker. Now, first thing we want to do is assign a data source, if you have one. That is also found under Users, Common Avatar System, Face, and it is Avatar Mouth Data Source Assigner. We're going to take our data source here, plug it into the target reference, and now when someone enters the avatar who has mouth tracking, it will be populated with the data source, and this will function as you'd expect. As you can see, it has the data source assigned, since Wraith here has a face tracker, and it assigned. However, you'll notice that even if he's moving his mouth around or whatever, we don't see it because there's no blend shapes set up. Conveniently, Neos has a handy-dandy auto-assign blend shapes button here. If I click this, it will populate it with a whole ton of various face tracking blend shapes if the avatar supports them. As you can see.
Should we also showcase like the stuff on like the pupil dilation and stuff like that too?
Yes. So if we scroll up here, we can see that a whole bunch of blend shapes are driven now. But you also notice it missed a few. And one in specific, just to demonstrate, is pout or pucker, which is that kind of mouth shape. This is not driven. We can add this to the expression driver ourselves by grabbing the value. And we're going to go all the way down. And we're going to add a new item here. Oh, I added a lot. We're going to put this into the target, and we're going to set this to pout. I'm going to delete the rest of these because, UIX spam. Now, if you pucker your lips, it does it. Great. So it actually looks like it set up a bunch of blend shapes.
Oh god, look at my lip!
Oh, what are you doing?
What? How?
Oh, it's oh yeah, if you bare your teeth, that does the angry expression, so it's just So as you can see with some avatars it might it might need some tweaking.
Yes.
That is a good screenshot. That is very nice.
Oh no, that picture.
Thumbnail?
Thumbnail.
We don't use thumbnails like this though.
I'm joking.
But that's for setting up expression drivers. Now, if you
I like that. They're on about how did you get the finger photo first time? Lots of practice.
I've been here for a while. So, if we want to set up some eye tracking blend shapes, those are usually by default located on the head. I'm going to select the head. And if we go under the eye manager. Oh, you have a gizmo in your face. Let me deselect. If you go under the eye manager, since Wraith also has eye tracking, all of these values here are associated with the actual eye tracking. So if Wraith winks, then it's appropriate. Now, to set up the eye tracking blend shapes, that's down underneath the eye linear driver component, underneath eyes. Now, if this list doesn't have any items, you can add one and set it to left or right. But since this avatar already has a few set up, we can see here this allows you to control things like the open-close target, which is blinking, the pupil size target, which we can see here is pupils. If I put something bright in front of the Wraith's eyes, it does change a little bit. You can also add, if you have blend shapes for looking up or down, you could put them in here, as well as eye tracking currently supports eye widen. However, there isn't a widen blend shape in here. I don't know if the Rex has eye widen.
I don't think it does actually.
That's unfortunate. Let me take a look. Eye wide, yes. So, for example, this is eye wide left. If I plug this into the wide target for the left and right eyes appropriately, now when Wraith widens his eyes, they widen. Kind of subtle, but yeah. You can see here that it's actually working. And yes, Ozzy actually does mention something interesting, is that this has the all of these look left, up, and right and down blend shapes here actually require a projection plane point, which for the sake of ease you can just set that to the eye manager itself. So now when you that's a good face. Now when you look up and down, I'm gonna just take a screenshot of that. That's good. If you come visit the world after the stream, there's gonna be a couple of very nice screenshots here.
Yeah, I just put my headset up on my head because I was doing something on the Twitch.
But now if you look up and down, the eyelids kind of move with the eyes a little bit, which lets you know that these are working. So the eye manager has quite a few blend shapes.
The thing is,
well.
actually, Paragon, with regards to the Rex, it does make a lot of people jealous anyway with the amount of blend shapes it has.
A lot of blend shapes. So many blend shapes. If you have a Rex, bake your
Bake your
blend
blend
shape that you're
shapes.
not using. For the sake of everyone's performance.
Yeah, I was going to say this one clearly doesn't have them baked because obviously we don't have this one baked because this is the one we use for stream work.
Mm-hmm. And this
But
also applies to any avatar that has a lot of blend shapes.
yes. Another really bad one is the Canis. It's actually by the same creator, and the Canis has even more blend shapes than a Rex because it can transform into loads of different types of avatars.
Oh, goodness. Yes, bake your blend shapes that you're not using. That is a nice PSA. Anyhow, that is the basics to setting up an avatar with face and eye tracking if you have it, as well as the blend shapes and gesture system that we basically made earlier. And since we only have just a few minutes left, I think that basically covers it for this stream.
Yep. Wapa. I still love that.
Cloud-based clothing. Okay. Now we head behind the desk. Oh, let's actually check if we have any questions that we haven't answered. Can you use logics to bind a key press to a gesture? Yes, if we had more time.
Yeah. Actually, we've got about 5 minutes.
Yeah, we do.
You could quickly go over it.
Yeah, let's do it right now. So, there we go. So, to do...
Let me just, before you start, just let me quickly take care of something. There.
Very nice. Okay. So, to do key press events, if you want to press a random key, or not a random key, but a given key on your keyboard to do something, that is also found under Input Devices, Keyboard, and we can look at, let's say, key held. Now, given an input key, which let's just say, let's pick one of these. There's so many keys. Okay, I'm just gonna spam it until I find a key. X. Okay, good enough. Now, I'm not currently at my keyboard, but if you were to press X, then this value would be true. One thing to note, though, is that this value is true only for you. This is a local value. If you want this to be true for everyone...
Works.
Hmm?
It works also. I can do this while I'm pressing on my keyboard, apparently.
Yes, it does, because it's local. So if we want this to be your X key held down for everyone, well, we can get user from username, because we are going to need a user in this case. I'm going to set this to, well, since you're at your keyboard, Aegis, I'll set it to you. Aegis, I'm going to have it so it finds you. Yep, there you are. And we need a flow fire on change. And all we're going to do when we fire on change of this value for this user is we're going to write this value to a variables storage value register of type bool. And now, if Aegis presses his X key, as you can see, it shows for all of us now. This is a generally basic setup of how you can have a local variable become a global one in this case, using a write.
Oh.
Because a write writes for
I have
everyone.
to hold it down to keep it true.
Yes.
Yep.
This is good. If you want it to toggle, well, we can, underneath flow, there's a Boolean latch. So, we don't even have to write the variable now. So if you want a value to toggle, all you have to do is toggle the toggle input of the Boolean latch, and you have a toggleable button.
I have to hold it down still.
Because it's fire on change, right.
You would do fire on true instead.
Yes, that would
I keep on forgetting that.
make sense. Yes, so that way you wouldn't want to fire on change, you'd want to fire on true. And now whenever it just presses the button, it's true, and then false, and back again. So this is how you can get keyboard input into Neos. Conversely, you can also, just while we're here, I suppose, you can also get mouse input. There's all sorts of nodes for
But yeah, just
for
remember
various
that is
mouse
key
input.
held. There is a key pressed as well, if I recall correctly.
Yes. There's key pressed. There is key released, and type delta, which good question.
God damn it, Delta.
Actually, I think this is the string that you're typing as you're typing it. Okay. But yes, getting off topic, but that is the basics for doing that. And now I'm just gonna go whoop, and get rid of that.
Funny as I can use WASD to still move around.
Oh, we actually have an interesting question. While we have a couple minutes left, what exactly is the difference between local and not local variants of the fire on nodes? So the not local variant has a user input, which allows you to get whether that value changes on that specific user, whereas the local ones will check that value locally for every user. So if a value changes for all users, then that node will send a pulse from every user, the local one. Whereas if the value only changes for, say, Wraith, then you will only get a pulse from Wraith.
Yeah. Oh, someone's asking how your eraser worked.
Ah.
The magic eraser.
All I'm doing for that is checking if there's logics inside this sphere. Find it, make sure it's logics, and delete it, and I can just be like, whoop, and it's gone. Very handy.
Ryuvi has a lot of cool little tools. So. Oh yeah. Did anyone notice anything different about the stream today, especially with the start? You could actually see us working in the background before the stream started.
Yeah.
On the background thing. Also, there is something else different in the studio. Has anyone noticed yet what's different in the studio? I wonder how many people have noticed it yet.
I wonder. I mean, it's not hard to miss.
No, it's not hard to miss.
Yes,
Yes,
the little stickers.
Yeah, the little stickers, yeah. Yeah, we've, there's little stickers. Hi, Angel Boy, you're late.
Hi, Angel, but also bye.
Yeah, we're ending in a minute.
In the stream.
But yeah, we've got our little cutouts hanging out over here now, so I'll just go into Smooth POV. Oh, that's on Ryuvi's Smooth POV. We want mine. But there we go, yeah, we've got Aegis, me, and Ryuvi. And we're just hanging out on the Workshop Wednesday logo.
I love it.
But yeah, again, I will say, if you've got topics that you'd like us to cover, we do have a feedback form on the Discord, which you can find at discord.gg/neosvr. And it's in our welcome and links, I think.
I believe so, yes.
I can never remember where the hell that stuff is anymore. It gets lost. Yay, online, hugs to you too. We will be having the world open for approximately an hour after we finished, as usual, so you can come along, come join us, come ask us questions, and, you know, ask, hey, how did you do that? Or all that good stuff. So we're available to answer questions. It doesn't have to be related to the gesture system that we've just worked on. It can be anything, like logics related or build related. But as I say, you know, if we can answer the question, we'll do our best to do so. We'll be returning in 2 weeks because we always take a break for a week after doing a workshop, unless it's a 2-parter, which this one is not. So we'll be back in 2 weeks with the workshop next Wednesday, same time, which is 2300 UTC. And we will also, well, I will be back, Magus might be as well, on Friday for our main Neo stream with Nexlin. So, I'm going to say goodbye. So, bye everybody. Have a good time. And so long for now. Wah-pa-pa. If you are looking for our world, by the way, just after to come over and see us, look for the workshop Wednesday world in active sessions. That's where you will find us.